So this is the second lesson in the circles unit. This is where I will introduce the words central angles as well as arcs. There is a relationship between the two, and hopefully at the end of this lesson you will see that. This curved section here along the circumference of the circle is called an arc. An arc is a portion of that circumference. A central angle is an angle formed by two radii. The vertex of that angle must be the center. This right here is the angle I'm referring to when I say central angle. A central angle's vertex must be on the center. And that being said, that's why it's formed by two radii. Now there is a relationship between a central angle and the intercepted arc. A central angle is congruent to its intercepted arc. So if I said that this central angle was 50 degrees, the crest or the intercepted arc would also be 50 degrees. Now in this particular unit, we are going to measure the arcs in degrees. Degrees is a unit of measurement. It is not the same as inches or feet or centimeters or meters. Degree is the form of measure we're using to refer to that portion of the circumference. First, we are going to discuss a minor arc. A minor arc uses two letters to name it. It is going to always be less than 180 degrees. So, if we're discussing an arc, we're going to use this curved symbol above the two letters. If we're looking for arc BC, that means we need to start at B and head directly to C. That purple curve is the arc I'm referring to when I say arc BC. Now I'm going to put a number and tell you that the measurement of arc BC is 135 degrees. 135 is less than 180, which makes it a minor arc. So arc BC is 135 degrees. If arc BC is 135 degrees, the central angle by which we intercept that arc must also be 135 degrees. We know that's a central angle because its vertex is on the center. So that A right there is the center of the circle. So because it's the center of the circle, it makes it a central angle, and a central angle is equal to its intercepted arc. So therefore it measures 135 degrees. Again, this is a minor arc because it is less than 180 degrees, and minor arcs are named with two letters. If we said BDC, we would have driven from B all the way around to the left to D and then to C, making that more than 180 degrees, and that's not a minor arc. So now let's look at the example to the right. It says that EC is the diameter. So if EC is the diameter, that means it cuts the circle in half. I'm going to write that down so that you understand what I just said. A diameter cuts a circle in half. So if a circle has 360 degrees, when you cut it in half, each half will have 180 degrees. We learned about this in the beginning of the year. These two angles here are a linear pair, which means they have to add to 180. Now, if the right pair adds to 180, the left pair also needs to add to 180, making a full circle of 360 degrees. I'm going to undo those so that we can go on with this problem. It says the measurement of angle BAE, so I'm going to highlight that angle. The measurement of angle BAE, they say, is 40 degrees. We must ask ourselves, is this a central angle? And the answer to that is yes, because A is the center and the vertex is on the center. So if that central angle is 40 degrees, the intercepted arc is also going to be 40 degrees. So right down here when it says arc BE, the answer to that is 40 degrees. Now, we just mentioned earlier that if this is 40 degrees, the rest of it must be its supplement, because that is half of a circle, being that EC was a diameter. And a half of a circle has 180 degrees. So 180 minus that 40 leaves us with a supplement of 140 degrees, which means right over here would be 140 degrees. And that is another central angle. That central angle is called BAC. Again, it's a central angle because its vertex is on the center. So if that is a central angle, this is its intercepted arc. So the next question says arc BC. Arc BC would also be 140 degrees because its central angle is 140 degrees. And then the measurement of angle BAC we also found was 140 degrees. Now, before I keep going, I'd like to fix a typo. This should say the measurement of angle CAD. So the measurement of angle CAD is 100 degrees. So I'm going to cross this out there. There is no arc CAD because A is not on the circle. So I meant to write the measurement of angle CAD is 100 degrees. So let's go ahead and fill that into our picture. The measurement of angle CAD. Another central angle because A is the vertex of the angle and it's also the center of the circle. So that angle is 100 degrees, which means so is this blue curve 100 degrees. I will put right there. So this next part here, arc DE, is what we need to look for now. Well, we could do this one of two ways. We can say, well, the angles, all of the arcs of a circle need to add to 360, or we can say all of the central angles inside have to add to 360. Either way will get us an answer. So we already have 180 plus 100, so that's 280. 360 minus 280 gives us another 80 degrees, which means this central angle is 80 degrees and so is its intercepted arc. So if it asks us for arc DE is 80 degrees and so is the central angle there. So this next question is a good discussion. It asks us to find arc DB. Now, if I start at D and drive to B, I could either head through E to B or I could head down through C to B. If there are only two letters, it's referring to the minor arc. Minor meaning less than 180, which therefore means I should be using the direction from D through E to B. This is what they're referring to here because there's only two letters. Therefore, that would be 80 plus 40, which is 120. That would imply that the central angle DAB will also be 120. And last but not least, arc DC, which we already found, and that was 100 degrees. The next part discusses a semicircle. A semicircle is half of a circle. Specifically, it will be 180 degrees worth of the circle because half of 360 is 180. So it is exactly equal to that 180. If the question asks for arc GHF, we go from G through the point H up to F. And if, in fact, FG is a diameter cuts a circle in half, creating two semicircles, which means arc GHF is 180 degrees. And therefore, angle GEF is actually a straight angle, and it also measures 180 degrees. It's really important to look for those diameters and those semicircles because that's a value that's given that's not really given. So we need to understand that if we have a diameter, we have two 180 degree angles. and that's extremely important. Okay, the next part says EC is a diameter. So just like earlier, from E to C, a diameter splits a circle in half. And then it also says that DF is a diameter, which would imply that this whole arc here is 180 degrees, and this arc here is 180 degrees, and so on and so forth. So it says that angle EAF, so let's highlight that in pink, angle EAF, well, EAF is a central angle because its vertex is on the circle, is 110, which would imply that this arc here is also going to be 110. And then it says that arc BF is 60 degrees. So let's highlight that. Arc B from B to F is 60 degrees. Well, that's nice, because if I know this whole arc here from E to F is 110 and a piece of it is 60, 110 minus 60 leaves us with 50, which means arc BE is going to be 50 degrees. And if arc BE is 50 degrees, this central angle here must also be 50 degrees. And if this arc was 60, inside of here, this central angle would also have to be 60. So if we look at the next part, it asks us for arc BC. Arc BC, because there's only two letters, would have to be a minor arc. So we're going to start at B and head to C, ensuring that we have less than 180 degrees, which would imply we'd go to the right through F. Now, if all together, from here all the way to here has to add to 180 degrees, and if a portion of it is 50 and 60, which is 110, 180 minus that 110 leaves us with 70 degrees. So this angle right here is 70, which means this arc out here is also 70. So if we want from B to C, that would be the 60 plus the 70, which is 130 degrees. Angle BAC would therefore also be that 60 plus 70, which again is that 130. Now arc DE. Let's look at something very old, but should be very new. We have these two red angles here. Those are vertical angles. And if you remember from the beginning of the year, vertical angles are congruent. So if this on the right was 70 degrees, the red one on the left needs to be 70 degrees. And if that central angle is 70 degrees, that intercepted arc is also 70 degrees. So the next part asks for arc DE, which means that that is also 70 degrees. Angle DAE is a central angle, and it is also 70 degrees. We found that by vertical angles. Arc DB, again, if they don't use three letters, it's a minor arc, which means your answer needs to be less than 180, which means we're starting at D, and we need to head to B and be less than 180 degrees, so it would be like this. And we need to look for the central angles that make up that arc. Well, we knew this one was 70 and we know this one is 50. So arc DB would be the 70 plus the 50, which is 120. Angle DAB is also that 120 because it's the central angle that goes to that intercepted arc. And last but not least, if we know that this is a diameter and therefore this is a semicircle, and if the left part of it was 70, The rest would be 180 minus 70, which gives us 110 degrees. So this angle here is 110, which means this intercepted arc is 110. So arc DC is 110 degrees. Always remember to look for semicircles and remember the value of 180. It will help you fill in the missing blanks to your puzzle. Last but not least, we have major arc. A major arc is always going to be more than 180 degrees, greater than 180 degrees. And it will always use 3 letters. That also helps us gives us the direction. So for here, we're going to start at B. We're going to drive through C and then get to D. As you can see, that's more than half of the circle, which would imply it's more than 180 degrees, which means it is a major arc. Now, earlier in a previous problem, I said that arc BD was 135. So let's do the same thing here. So if this minor arc is 135, the major arc is always going to be 360 minus that minor arc to make up the whole circle, which leaves us with 225 degrees. So major arc BCD is 225 degrees. EC is a diameter, which is important because it will split the circle into 2 semicircles, a left semicircle and a right semicircle, each one adding to 180 degrees. The measurement of angle EAB is 45 degrees. So from E to A to B is a central angle because its vertex is on the center. That's 45 degrees, which means the crust, aka the intercepted arc, is also 45 degrees. Then it says the measurement of angle ECD, the measurement of arc ECD, which is 280, which again, because there are 3 letters, a major arc is denoted by 3 letters. We're going to go from E. First, we have to go through C, then to D, which would imply we'd have to go all the way to the right, and then finally to D. If we just went from E back to D, we'd be less than 180, which would be a minor arc. So that is 280 degrees. That whole purple curve is 280 degrees. Well, if that's 280 degrees, and we're really only missing this curve, arc, crest, whatever you want to call it, right there, then we know that 360 minus 280 will give us the rest of the circle. So this piece right here would have to be 80 degrees because this pink all the way around plus this purple all add to 360. Let's answer these questions. Arc BE. Arc BE we knew was 45 because the central angle was 45. Arc BC. Well, from B to C is just this portion of the circle. That's going to be the same as this central angle. Well, we know that this was a diameter, therefore this is a semicircle. A semicircle has 180 degrees in it. So 180 minus 45 leaves us with 135 degrees for this central angle here, which means this yellow arc is 135 degrees. BAC is the central angle we just used to find the measure of that arc, therefore it's also 135 degrees. Now we have arc DE. We already found arc DE by finding the rest of the circle, so arc DE is 80 degrees. Angle DAE will also be 80 degrees because it is the central angle to that intercepted arc. Now we have arc DB, only 2 letters, therefore it's a minor arc. And arc DB starts at D and will go through E to B because if we went the other way around, it would be more than 180. So therefore that's going to be 80 plus 45, which is 125. I'll go like that. Angle DAB is the central angle to that orange arc. So therefore, if the arc is 125, the central angle must also be 125. And last but not least, we have arc DC. Arc DC is just this gray arc right here. So if we knew that these two together have to add to 180, and if this one was 80, this has to be 100 to make the other half of that circle 180 degrees. And if that central angle is 100 degrees, then that gray arc must also be 180 degrees because we have a central angle and its intercepted arc. Please make sure you've answered all of the questions and then go ahead and do the quizzes associated with this lesson.